But radicals first. What do I mean when I say a radical? In square root form, absolutely. Something like this. So we had some radicals on your warm-ups, and it looks like everybody got those mostly right, especially the ones that were perfect square roots. So if you have something like this, tell me what's going through your head when you look at that. How do you know 5, but why? What does 5 times 5 is 25. So give me a more general form. If you were explaining to someone who had never seen a radical before what it means, what would you tell them?
Number times itself equals what's under the radical.
A number times itself twice, and that number must be the same number, right?
Yes.
So 5 times 5 is 25, right? So it gives you 5. So a number times itself twice. Is 5 the only thing that solves that is a solution to that?
Yes.
So the square root of 25 can be 5 and only 5 and nothing else. Everybody agree?
Yeah.
What is that?
25. Negative 10.
Uh-oh. So it could be a positive 5 or... Does that make sense to everybody? It has 2 answers. So we use a little symbol that looks like this. And I'm going to just draw an arrow here to tell us that the answer could be positive or negative. That's a plus or minus sign. Does that make sense to everybody? Going too fast? Okay. I'll give you a second. Tell me some numbers that are perfect squares that you would get a whole number answer for if you put it under a radical. In other words, like square root of 25.
149.
I hear 49. I hear 144.
36. 64.
How about we make a list in order? How about that?
Okay, 1. Oh, yeah, 4.
Because this is going to be your key to being successful here, is being able to recognize these perfect squares, okay? Let's go. We're ready in order. 1.
4.
How did you get 4?
2 times 2 equals 4.
Okay.
9. 16. 25.
I'm going to write out here 2 times 2.
30.
All right, what's the next one?
36. 25. 36.
Guys.
42. No.
36.
Oh my goodness, y'all are getting ahead of me. Okay.
49.
All together now. 49.
64.
81.
100. 120.
Wait, don't get ahead of me.
You're the one that's
121, you said.
144. What is it, 169?
Wow.
169, and then you got 196.
Then you got 203.
It's 196 now.
One more I want you to be able to recognize.
225. That's how much I weigh.
256.
Okay, I want you to be able to recognize up through 225 as being perfect squares, and you're going to see why it's important. Now, if you don't recognize it right now, that's okay. We're going to practice so much. What's wrong? Absolutely. Anything I write down, you should write down.
Do we have to?
told you what to write down.
Ooh, so you're writing down what we told you.
So if I go notebook check, turn to your notebook and copy down.
I'm teaching you.
Yeah, you're teaching me.
I know.
Because I did not know my list of perfect squares. Good job, class.
We know you feel like you have to.
I want to tell you something special, guys, about radicals. When you have two things multiplied together, I'm going to use variables to illustrate this at first. And I'll show you.
I'm still remembering the ones from last week.
What?
I'm still trying to write the ones from last week.
All right, when you got two things multiplied under the same radical, what happens is I can break them apart under separate radicals as long as I know that I'm multiplying. How many of you remember doing this? Do you?
Somewhat.
Yes.
I remember pieces of it.
So, Miss Wilson, yes, Miss Wilson should have taught you that.
Lopez.
Oh, I thought you said Miss Wilson. All right, so this is convenient because if I had a perfect square under here, let's go back to that same 25 times 2. I could break this into two different radicals multiplied together, yes?
Right.
25 and 2.
What? Something like this?
And this is convenient because the square root of 25 is what?
5.
5.
Okay. What?
The process in going through, yes. So we're going to use this technique to simplify radicals.
This is a lot of technique.
It's one technique. Simplifying the radicals. All right, I told y'all I like steps when I'm teaching you something new, right?
Yes.
So, here's what we're going to do. The first thing we're going to do, and I'm going to run, I'd like to show you steps on one side. I should say this is how to. And an example on this side. So, when you're asked to simplify a radical, and every time you deal with radicals from now on, you will be expected to simplify them. Let's do... I'll give y'all a second to copy that. Okay.
36 and 37.
Here's what I want to do. Find the biggest.
6 times 6. Square root of 6 times square root of 6.
Find the biggest, guys, perfect square from that list that I gave you. And I'm just going to write PS for perfect square. That goes into your number evenly. PS means perfect square, yes.
That's what it means on letters too? No, Trey.
Now, I don't have the list over here anymore, so I'm just going to write, as y'all copy that, I'm going to write my list of perfect squares off to the side here. 4, 9, 2, 3, 16, 25, 36, 49. I forgot 64.
Yeah, 64.
But I know I don't need to go any further because if you look at the number, I don't need to go over 72 for sure, right?
Yes.
A good little tip is you really don't need to go past about half of the number. Okay, so if I'm talking about 72, I'm gonna look. Maybe I'll start somewhere here and start working my way up to see which one I can divide evenly by. Does that make sense?
Yeah.
The biggest one you can divide and not get a remainder when you divide.
36.
Okay? 36, absolutely. Because
36 times 2 is 72.
36 times 2 is 72. So I know I'm going to use the number 36.
That has nothing to do with
Sure it
We gotta
does.
do that every time with every number. Are you serious?
this. Why the hell are we using 36?
I'm lost.
All right, look. This list over here is a list of perfect squares, yes?
Yes, ma'am.
If you take out your calculator and you say 72 divided by 49. And let me show you.
Get a remainder.
You get a remainder, absolutely. 72 divided by 49. That one does not work.
Where you get 49?
I'm working my way up this list to see what the biggest one is that will go into 72. So 49 did not work. 36
What?
does work. You see that? There's no decimal. It's a nice even number. Yeah.
6 over.
So we should get a decimal, we should put it over.
There.
All right. So you go until you get a whole number whenever you divide it. Are you with me now? Does that make sense? Shh, shh, shh. Okay. Work your way up the list and keep dividing this by the numbers on this list, but you want to start from biggest to smallest. Okay.
So once you find the biggest number, you can stop?
You stop. And what you want to do is write it as a multiplication problem. So we're basically, and I'm going to say under a multiplication problem under,
How often do you check notes? So we can just listen to you. Write notes, go online and listen.
you need to write them down. Okay, 36 times what gives you 72? 2. So I'm going to write it as a multiplication problem under the radical. Is everybody with me? Now my last thing I want to do is take out the perfect square.
They got 72.
It was 72, but do you agree that 72 is the same thing as 36 times 2? Yes? So then I can break this apart, take that perfect square and put it on the outside. And the square root of 36 is 6. It is what you just said. Throw that plus or minus sign in the front. Okay, it always goes in the front there. Don't put it in between. Put it in the front because it could be positive or negative.
And we just put 2 to the side of it.
Yes, the 2 stays under the square root. You know you are done.
That's pretty simple.
When there are no perfect squares that can go into what's left, then you're done. Yes, you may. Okay. Do what? No, it does not. We'll do one that's not 2 in just a second. We'll do one that's not 2 in just a second. Yeah, yeah. I did because 72 divided by 36 is 2. You have to write it as a multiplication problem here. So we found out that 36 was the factor, but you have to rewrite 72 using that. So 36 times what gives you 72? 2. Well, this is convenient. My book just fell apart. Let's do another one. Are y'all caught up with this one? Let's try this one. And we're starting out easy.
Oh my God.
Now remember, one of the things must be a perfect square when you break it apart, okay? So I tend to do it,
Wait, Miss Mig,
yes,
wouldn't it be 9 and then times 9 by 3?
absolutely. Y'all see what he did?
Yeah.
If you look at your list of perfect squares,
4, 9, 6.
So your answer is going to be
the biggest one of those,
3 and then radical sign.
yes. The biggest one of those that goes into 27 evenly is 9. 27 divided by 25 will give you a decimal. 27 divided by 16, decimal. 27 divided by 9
The whole number.
is 3. So 9 times 3 is 27. Do you agree?
Split them up.
Split them up.
I have to write down like all these examples.
Gil.
So I got the.
Oh, that's what I have.
All right, think about this one before you answer it, okay? Because this one's a little confusing, yes. Don't blurt out the answer when you get it. Let's see if we can all get to the right answer. Simplify that expression. As you look through your list of perfect squares, what is the biggest perfect square that you found that will go into 28 evenly? Yes. 4. 4 times what gives you 28? 7. I use this one because 4 is a perfect square. So split them up. Square root of 4 and square root of 7 gives me... Now understand, and I think this is important for me to tell you because of what I'm fixing to show you, this is being multiplied here. There's not a sign there, but it is being multiplied. Does that make sense to everybody? Yes. Okay. So what if... You ready to kick it up a notch?
No.
Come on, it's fun.
Sure.
Make it a little bit more challenging.
What if I had something that looks like this? It's already got a number on the outside, but it's not under the radical.
Oh, I remember this. You multiply 5 by itself.
Close. This is out here. Do you agree? Can I break 24 down? No?
Yes, you can. Yeah.
Sure you can. What perfect square goes into 24? 4. 4 times what? 6. So I'm going to just keep writing what I know. This is times, right? 4 times 6. Break it apart, absolutely. So I got 5 times the square root of 4 times the square root of 6. Now what?
Multiply.
Multiply what? 5 and 4?
5 and 6.
Sure.
Well, wouldn't you go down lower?
Do you agree? Yes. Do you agree that this is all multiplied?
Yeah.
It's not a distribute problem. It's not 5 times square root of 4 plus square root of 6. If that's the case, it would go to both. But that's not what it is. If I have, okay, so y'all are both saying the same thing. You still make the square root of 4 too. You agree with that?
So 10.
So 10.
Square root of 6. Positive.
You can't run. Wait, what?
Let's see if you understand.
John, if you're out.
Let's take the one we just did, but now let's multiply that. Now remember what I was just saying when we multiplied, when y'all got confused, okay? Still look at it as this is 4 different things being multiplied together.
Oh, slow down.
No, you can just bring the 5 and the 3 together.
You absolutely can. Why?
15.
What's that property called? When you can...
Like terms.
Not like...
Contributive.
Commutative property. Multiplication is commutative. Good job. Means I can multiply in any order I want to, as long as that's all I'm doing. Okay.
15 and 24 and 10.
So it's 15.
24. 20. And you can do break 24 down.
Okay.
24 breaks down to 6.
And so y'all are doing 24 breaks down into this. Is there another way you can think that you might be able to do this problem?
24 times 2.
Is there a longer way to do it?
It's 240.
I could, remember that property I showed you said that A times B is the same thing as the square root of A times the square root of B.
Yes.
So could I also go backwards with that? Could I say the two together, I could multiply under the same radical.
So 15
Yes.
minus 240.
And so by doing that, I'm going to make one less step on myself when I find that perfect square.
240?
Am I going too fast?
No.
Sure.
Not at all.
Okay.
Because now it's just 40 and 6.
So now let's take a minute to find, but 40 is not a perfect square. 4 is, but 40 is not. Go through that list of perfect squares, see if you can find it. Don't blurt it out. All right, let's see. Darian said 64.
It is.
All right, so here's the process we're going through.
Why no?
81 is what you said? No.
36.
Try 36. No.
49.
Oh, you better. I found it. That's right.
Exactly. Then
I
it's
told
like-
you it was 16 the first time.
No, you did not.
Okay, yes, yes, stop.
16 times what?
32. 15.
Times 15. I was going to say it was just on the calculator. Shh, shh, shh.
So you got 15 and 4 and 15.
So now I got 15 times the square root of 16 times the square root of 15. Square root of 16 is
4.
4. No, Darian. 15 times 4 is
60.
60.
Super smart.
Good job.
Please understand that this and this are two different things. What's the difference in those two things written in blue on the side?
Top line could be
15 is negative and positive. 60.
This is saying 60 times the square root of 15. One time the whole thing is positive, one time the whole thing is negative. This one is saying 60 plus the square root of 15 and 60 minus the square root of 15. Remember, we are multiplying, not adding and subtracting. Does that make sense?
Yeah.
Okay.